Okay, in this worksheet, we're checking to see if there are congruent shortcuts. We'll find out shortly that certain patterns of congruence will let us say that things are congruent, like angle, side, angle, side, angle, side, angle, angle, side, or side, angle, side. So for the first three, you should copy those segments and angles onto white paper and experiment around to see how many different triangles you can come up with those combinations of sides and angles. For number 4, we have parallel lines, which set up a couple of different transversals and alternate interior angles, which I have marked in blue and in pink. The pink ones go together and the blue ones go together. We also have that vertical angle in the center. So that gives us 3 angles that are congruent. But in terms of the special patterns that it takes, we've got angle, side, angle, which would be like angle P, and then the side AP, and then the angle at A, matches angle I, the side between I and M, and then angle M. So that would give us the angle, side, angle pattern. Angle, angle, side would use the vertex angle, or the angle at T, along with A and the side, or the angle at T along with P and the side. And with the other triangle, it would be the angle at T along with M and the side, or the angle at T and I in the side. Number 5 is congruent because of side, 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 and so is number 6. Now, if M is the midpoint of both of those segments, then PM and MQ are congruent, and AM and MB are congruent. We have a vertical angle in the center, and that sets up a side angle side pattern that we could use to say that those triangles are congruent. And then we have to be careful to name things in the right order. With the kite, because it's a kite, we have 2 pairs of consecutive congruent sides. Also, the long diagonal bisects the vertex at I and the other bottom vertex at E. That's properties of a kite. Another property is that the TK segment would be perpendicular to the IE segment, and that the angle at T would be equal to or congruent to the angle at K. But by side angle side, using the vertex angle bisected by the diagonal, we have side angle side pattern. For ABC to be congruent to some other triangle, if we look at what we're given, we have parallel lines, but those aren't the same transversals, and there really isn't enough information, so it cannot be done. For number 10, triangle MON, if we look at what we got there, we've got parallel lines cut by transversal, so angle TNO and angle MON are congruent, and NO is congruent to itself as a side, so that sets up a side angle side pattern. With number 11, we have the vertical angle at H. Vertical angles at H are congruent. We've got a side, SR, and another side, SU, but there's really not enough information about these others. Do we have alternate interior angles? No, we do have alternate interior angles. So back to number 11, that's actually an angle side angle pattern, not a cannot be done, because the angle at S is congruent to the angle at U, because alternate interior angles with the parallel lines, no, there's no parallel lines there, so forget that. 11 actually is a cannot be done. With number 12, we've got, they're telling us which matching angles are congruent in the congruent statement, and to go from one to the other, from one point to the other on the bottom triangle, we can do the reverse image and do that on the top triangle. So D is, or O is, like back 4, down 2 to get to T, so we add 4 and add 2, and that'll give us D, and so on. and that'll give us our coordinates on that one. So try these and check them out.